Wow, Assalamu alaikum. Beautiful day in Lahore. It is 6th of July 2025. Continuing with my earlier rock series where I was trying to explain that how the digital world has been designed through a complex non-linear understanding of not only through uh, complex simultaneous equation modeling, whereby non-linear linearities were identified through both time series and cross section, whereby several qualitative and quantitative controls have led to different kind of programming techniques and coding techniques to develop web applications or to then introduce advanced language artificial intelligent language models or then to have better visual uh, techniques, like for example that could be evident from social media like YouTube or X or TikTok. Not only that, uh, there would be an complex three-dimensional understanding of how complex set of quantification would work to then create coding and programming for three-dimensional spatial graphics. So I started with an example, great example of classical wall clocks. If you try to observe classical wall clocks as suggested, there would be three needles, hour, minute, and second, and they will definitely be moving around with providing a time frame of 12 hours and 24 hours, and then would be formatted into a calendar for months and years. Now here, what I have brought was that how you would establish connection, a symmetrical connection for one time zone. Then would mean that maybe the needle of hours, minutes and seconds have are at the same point in the wall clock, and then there would be yet again a variation. That's what is the estimation strategy for the most complex nonlinear mathematical algorithm. That the connection where all the needles are at the same point would then be identified, and then again would then transform into another new complex variation, but still measurable because we know that minutes there are in a minute there are 60 seconds, and in an hour there are 60 minutes. So while we are having a time variation possibilities and probabilities and all of them controlled and established and could really be modeled within the framework of a classical wall clock, we need to understand the spatial variation as well. But before that, what would be the utility of understanding a complex spatial variation would mean that as if two people, one sitting in somewhere in North America, one sitting somewhere in Asia, would come up with the same idea. And that happens a lot, very often in scientific community when one professor comes up with the same idea as a professor sitting miles away in another university. And that's the basic framework of that how a connection is established, whereas the time framework is the same, variation in the clocks, but the spatial framework is different, and the spatial framework is defined through it's not through a flat and straight and horizontal proportional possibility, but a spherical, yet more complex and more refined three-dimensional 360-degree framework, because Earth is a sphere. So what I'm saying is that it means that there is a lot of variation within the time, which will be called time zones, and then all geographic locations have their own time zones. Imagine these three needles of a classical wall clock, when added spatial variability, would suggest numerous time zones, and would even be calculated for 24 hours. After 24 hours, a day is completed. Now, what is this understanding? Basic understanding. It's basic, but yet complex time variation through different time zones, and spatial variations through understanding spherical geographical nature of planet Earth. But still, this is all built on theoretical presumptions. Would then be interesting to start modeling such a three-dimensional variation. Would then yet allow us to then build some really robust two-dimensional frameworks. What it would translate into is that if we can combine variation in the time zones with certain spatial definitions, that it's a time zone for Pakistan, it's a time zone for Africa, it's a time zone for Europe, it's a time zone for North America. What we are doing is that we are building from a certain spatial location, 24-hour mapping of variation, whereas the variation mainly is based on time, and then controlling it for a certain spatial location. And my friends, that's how the basics for developing a GPS system, or then understanding how the satellites would map the universe, like TESS would map the universe. It is a technique to then understand tesseract as well, mapping the universe through 360 framework could not be explained better and more simpler than how I have established the cognitive understanding of complexity, not only in mathematics, but spatial horizon and graphic analysis, from a simple classical wall clock and presenting the possibility of different time zones, and also the spatial complexity of planet Earth. So that's how complexity would work, and then lead to many inventions, many understandings. Simultaneously, spatial understanding is leading to complexity in programming to develop better and better methods, which could allow more, convenient frames in 2 dimension, and that would be, great audio clips and video clips. Or it would allow complex models that could then define an artificial intelligent language model, like Microsoft Copilot, ChatGPT, or DeepSeek. And there are the same methodology and understanding of the complexity that could be understood of a 3-dimensional space, not only through a spatial variation, but also time variation. And that is simply to understand how non-linear communication and connections are established between, let's say, 2 people, or 1,000 people, or 1,000,000 people. And what would be the greatest data set for, especially an artificial intelligent language model, would then be all the random chatter, all the random communication that might be happening in social media. Or, I mean, that would be a great data bank to then understand uh, and code the responses and the source codes for a language model, artificial intelligence language model, to seem a little bit more intelligent, to understand uh, near infinite expressions that would establish uh, different levels of connection based on, knowledge, based on happiness, based on commitment, based on emotions, or based on friendship, or based on recognition towards all these variables. And then, of course, in social media, billions of people have been exchanging their views, connecting, expressing themselves to create a large set of information to then, be coded through the same complex variation that I've explained, to the spatial and time variation understanding that could be understood from a simple wall clock, and understanding the time zone and spherical context that will allow spatial identification through where you are connecting to the internet on planet Earth. And therefore, that cognitive understanding, whereas wall clock is a centuries old technology, classical wall clock, but then that simply would create, in the first place, technologies to then identify locations, like for example GPS, and with time, it would then be the building blocks for the digital world. And of course, it's the same complex but yet simple methodology to understand variation in time and spatial horizons within three-dimensional frameworks would then simplify it, and it would allow to then develop technologies that are used in satellites. For example, TESS could map the universe or the Milky Way through building up frames, mapping up frames which are defined through time and spatial orientation, and developing a direction, and then building up a 360 universal frame to identify, galaxies, or maybe could identify how the universe is expanding, or there could be many other aspects of time and spatial aspects that could be mapped and framed by TESS satellite. And that's if you could understand how a wall clock, simple classical wall clock works, and then start imagining there are so many different time zones, and that would be identifying different locations in the world, and those locations identify a certain culture, certain communication methods, would then start building up source code for a complex understanding, a non-linear understanding, which could, if you're a mathematician, would enable you to develop one of the most complex mathematical algorithms while building them through certain variables, then identifying them through their sub-definitions and identifications, and then there would be an interactions which could be derived, defined, or for which data could be collected. And that's how complexity would work, by simply making an effort of quantification and finding the right methodology for what is the purpose of that quantification methodology, would allow you to understand how the digital world came about in 21st century, or how space technologies would define satellites like TESS to then map the universe, or then would allow you to understand how complex language model algorithms would be created to then define artificial intelligent language model like ChatGPT and Microsoft Copilot.